In last lecture we start application of determinants. In that we discuss Cramer's rule for solving linear equations in two variable, linear equations in three variable. Then today we discuss consistency of three equations in two variables, and then area of a triangle and collinearity of 3 points. So first we discuss consistency of three equations in two variable. Now we are familiar with the linear equations, simultaneous equations in two variable. So a1x plus b1y plus c1 equals to 0. This is a linear equation in two variable, and we know that this is general equation of line. And if we consider here a2x plus b2y plus c2 equals to 0, if these two equations are the equations of two lines, and if these two lines intersect, that means they have common point. That means if we find point of intersection, that value of x satisfy both these two equations. Similarly, for consistency, if three lines satisfy by variable xy, equations of these three lines satisfy by this xy, then that three equations are consistent. So we write here, if third equation as a3x plus b3y plus c3 equals to 0, and if this xy satisfy all these three equations, then we say these three equations are consistent. That means they have same solution, or we say they have a common point. So if we find value of xy from any two equations, suppose we find value of xy from equation 1 and 2, and we substitute the value of xy in equation number 3rd, then this equation 3rd is satisfied if these three equations are consistent. So instead of solving this simultaneous equation, we check the consistency by writing the coefficient of x, y and these constants in the determinant, and if the value of this determinant is 0, that means we have to find a1, b1, c1, a2, b2, c2, a3, b3, c3. If this determinant value is 0, then these three equations are consistent. Then next, area of triangle. If a of x1, y1, b of x2, y2, c of x3, y3 are the vertices of triangle. Now here we consider triangle ABC, whose vertices are a of x1, y1, b of x2, y2, c of x3, y3. So A, B, C. Now we have to find area of this triangle ABC. Then we write here area of triangle ABC is equal to half of, in determinant we write in first column x coordinate. So write here x1, x2, x3. In second column we write y coordinate, y1, y2, y3, and in third column we write 1, 1, 1. So using this formula we find area of triangle. Now here collinearity of 3 points we check with the help of this determinant. If area of triangle ABC equals to 0, if area of triangle ABC is equals to 0, then these 3 points are collinear. That means here these points A, B, C lie on the same line. If these 3 points lie in the same line, then that time we get area of the triangle equals to 0. So with the help of this determinant we can check whether the given points are collinear or not. Now see question number 1 from exercise 4.3. Solve the following linear equations by using Cramer's rule. So in last lecture we solve sub question 1 and sub question 2 in class. So we solve here sub question 3rd. Here first equation is x plus z equals to 1, second equation is y plus z equals to 1, and third equation is x plus y equals to 4. That means here these three equations are linear equations in three variables. So we have to introduce the hidden variable. So here variable y is absent, so we write 1 into x plus 0 into y plus 1 into z is equals to 1. This second equation we write 0 into x plus 1 into y plus 1 into z is equals to 1, and this third equation as 1 into x plus 1 into y plus 0 into z is equals to 4. So calculate the value of determinant d first, that is coefficients determinant. So here we write d equals to, we write coefficients of x in first column, so 1 0 1, coefficients of y in second column, so 0 1 1, coefficients of z in third column 1 1 0. We solve this determinant along first row. So right here plus 1, then 1 into 0 is 0, minus 1 into 1 is 1, so 0 minus 1 we get minus 1, so we directly write 1 into minus 1, then minus 0 plus 1 in bracket. So for plus 1 we skip first row, third column, so right here 0 into 1 is 0, minus 1 into 1 is 1, so 0 minus 1 we get minus 1. So right here value of this determinant is equals to 1 into minus 1 is minus 1, 1 into minus 1 is minus 1, so minus 1 we get minus 2. Then we find dx. For dx we write the elements in first column instead of coefficient of x, that is by constant. So we write here in first column constant 1 1 4, then 0 1 1, then 1 1 0, plus minus plus, solve this. So 1 in bracket, again 1 into 0 is 0, minus 1 into 1 is 1, so 0 minus 1 we get minus 1, this minus 0, then plus 1 in bracket. Here we skip first row, third column, so 1 into 1 we get 1, minus 4 into 1 4, so right here 1 minus 1 is minus 1, 1 minus 3 is minus 1 minus 4 is minus 3, so 1 into minus 3 we get minus 3, which is equals to minus 4. Then we find dy, then we write value of dy is equals to, so in place of this coefficient of y we write constant in second column, so write 1 1 4 in second column, keep first column and third column as it is, so 1 0 1, then 1 1 0. Solve this determinant along first row, so write plus minus plus, so we write here 1 in bracket, 1 into 0 is 0, 0 minus 4, that is minus 4, minus 1, so for minus 1 we skip first row, second column, 0 into 0 is 0, 0 minus 1 into 1 is 1, so 0 minus 1 we get minus 1, for plus 1 we skip first row, third column, so 0 into 4 we get 0, minus 1 into 1 is 1, so 0 minus 1 we get minus 1 here, 1 minus 4 minus 4, minus minus get plus 1, 1 into 1 minus 1 is minus 1, so plus 1 minus 1 get cancelled, we get minus 1 as the value of dy. Then we find dz. So for dz we write in place of 1 1 0 1 1 4, so right here in third column 1 1 4, and keep this first and second column element as it is, 1 0 1, then 0 1 1. Now solve this determinant along first row, so write plus minus plus is equals to, so plus 1, when we consider plus 1 we skip first row, first column, so calculate determinant of 1 1 1 4, so 1 into 4 is 4, 4 minus 1 into 1 is 1, then minus 0 plus 1 into, so we skip first row third column, 0 into 1 is 0, minus 1 into 1 is 1, so 0 minus 1 we get minus 1, so right here 1 in bracket 4 minus 1 is 3, minus 0, 1 into minus 1 is minus 1, so directly write minus 1, 1 into 3 is 3, 3 minus 1 which is equals to 2. Now we have the value of dx, dy, dz. So we find here x, so x is equals to dx upon d. We find y is equals to dy upon d. Then we find z is equals to dz upon d. Now substitute value of dx as minus 4, so minus 4 upon d, value of d is minus 2. So here we get minus minus cancel. We divide this 4 by 2, so we get here x is equals to 2. Then for y is equals to dy upon d, dy is minus 4. So right here minus 4 upon minus 2, which is again plus 2. Then z is equals to dz upon d. Value of dz we calculate 2. So 2 upon minus 2, which is equals to minus 1. So in this way we get x is equals to 2. Y is equals to 2, z is equals to minus 1 as the solution of this three linear equation with the help of determinant, and this method we call Cramer's rule. Now see next sub question 4. Here first equation is minus 2 by x minus 1 by y minus 3 by z equals to 3. Then second equation is 2 by x minus 3 by y plus 1 by z equals to minus 13, and third equation is 2 by x minus 3 by z equals to minus 11. So we write this third equation as, instead of writing as it is, we introduce here variable z. So write 2 by x plus 0 into 1 by y minus 3 by z is equals to minus 11. So we solve these three equations, first, second and this last. So write in solution. We solve this by using substitution first. That means we have to write this 1 by x as capital X, or you can directly write instead of x 1 by x. So we write here this 1 by x. So right here put 1 by x is equal to capital X, this 1 by y as capital Y, and 1 by z is equal to capital Z. So write these three equations. So write here minus 2x minus y minus 3z is equal to 3. Then this second equation as 2x minus 3y plus z is equal to minus 13, and this last equation as 2x, here we write plus 0y minus 3z is equal to minus 11. So first we write determinant d from this. So write determinant d is equal to, so elements of determinant d are minus 2 minus 1 minus 3, minus 2 minus 1 minus 3, then 2 minus 3 1, 2 minus 3 1, then 2 0 minus 3, 2 0 minus 3. So we solve this determinant along first row. So write here plus minus plus. So here plus minus minus 2 in bracket. We skip first row, first column. So write 3 into minus 3, that is plus 9. So plus 9 minus 0, we get 9. Then minus minus get plus 1. So 1 in bracket. Here we skip first row, second column. So 2 into minus 3, we get minus 6. So write here minus 6. Then 2 into 1 is 2. So write minus 2. Then plus minus minus 3 in bracket. So here we skip third column, first row. So 2 into 0 we get 0, 0 minus. So we write here minus minus plus 2 into 3 6. So we get here plus 6. Now write this minus 2 into 9 which is minus 18. Minus 6 minus 2 we get minus 8. Then minus 3 into 6 which is minus 18. So we get after adding this as minus 44 which is not equal to 0. Then we find value of dx. So right here dx is equal to in determinant. We have to write in place of minus 2 to 2 constants 3 minus 13 minus 11. So write 3 minus 13 minus 11 and keep the second and third column element as it is, that is minus 1 minus 3 0, then minus 3 1 minus 3. Now solve this determinant along first row. So write here plus minus plus. So we write here plus 3. So plus 3, when we consider plus 3 then we skip first row first column. So minus 3 into minus 3 which we get plus 9. So write here 9 minus 0 as 9. So minus minus get plus 1. In bracket we skip first row second column. So here minus minus get plus 13 3 are 39 minus. So here minus minus get plus 1. So we write here plus 11 into 1 we get 11. Then plus minus minus 3. So write minus 3 in bracket. So we skip first row third column. So minus 13 into 0 we get 0. 0 minus this minus sign and these two minus signs. So we get minus 3 times. So 11 into 3 we get 33. So right here 9 3s are 27. So here first we add 39 with 11 we get 50. So 50 into 1 we get 50. 50 here minus minus get plus. So 33 3s are 99. So we add these three values. So we get 176 as the value of dx. Then we find dy. So dy equals to, so for dy we write the coefficient of y. In place of coefficient of y, the constant 3 minus 13 minus 11. So write in second column 3 minus 13 minus 11 and keep first column element as minus 2 2 2. Then third column element minus 3 1 minus 3. Now solve along first row. So write here plus minus plus which is equal to, so plus minus minus 2. So minus 2 in bracket. So here minus minus get plus 13 3s are 39. So we write here 39. Then minus this minus sign minus minus get plus 11 1 are 11. So plus 11. Then minus here 3 into minus 1 we get here minus 3 in bracket. So here we skip first row second column. 2 into minus 3 we get minus 6. So minus 6 minus 2 into 1 is 2. Then plus minus minus 3. So right here minus 3 in bracket. We skip first row third column. 2 into minus 11 we get minus 22. Then minus minus plus 2 into 13 we get 26. So right here minus 2 in bracket. 39 plus 11 50. Then here minus 6 minus 2 we get minus 8. Minus minus plus 8 these are 24. Then here minus 22 plus 26 we get plus 4. So 4 into minus 3 we get minus 12. So right here minus 2 into 50 as minus 100. Here 24 minus 12 which we write here plus 12. So minus 100 plus 12 which we get minus 88 as the value of dy. Then we write dz. So write dz equals to in determinant. So we write in third column 3 minus 13 minus 11. 3 minus 13 minus 11 and keep first column and second column element as it is. So write here minus 2, 2, 2, minus 1, minus 3, 0. So write here plus minus plus because we solve along first row. So write here plus minus minus 2 in bracket. We skip first row, first column. So here minus 3 into minus 11, we get minus minus plus 3 into 11 plus 33, minus 0, 0 into minus 13 is 0. So we write here 33 minus 0 as 33. Here minus minus get plus 1 in bracket. So we write here 1 in bracket. So we skip first row, second column. 2 into minus 11, which we get minus 22. Minus minus get plus. So write here 2 into 13, that is 26. Then plus 3. So plus 3 in bracket. We skip first row, third column. 2 into 0 is 0, minus. So minus minus get plus. 2 into 3, 6. So write here minus 2 into 33, which is minus 66. Then minus 22 plus 26, which we get 4. 4 into 1, we write 4. Then 0 plus 6, 6. 6 3s are 18. Now we add 4 with 18. So write minus 66. Here 18 plus 4, we get 22. So here minus 66 plus 22, which is minus 44. So we have dz, dy, dx, d. So by using the formula, now these are the capitals, capital dx, capital dy, capital dz, because we substitute 1 by x as capital X. So write here, therefore capital X is equal to dx upon d, capital Y is equal to dy upon d, and capital Z is equal to dz upon d. Now substitute the values first here. So dx is 176. So write here 176 upon value of d is minus 44. Then dy is minus 88. So minus 88 upon minus 44. Dz is minus 44. So minus 44 upon minus 44. So we solve this, we get here minus 4. Here minus minus get cancelled. 44 2 is 88. So we get here 2. Here minus minus get cancelled. We get 1. Now these are the values of capital XYZ. And we have to find small xyz. So write here small x is equal to 1 upon capital X. Because when we interchange here, we take capital X equals to 1 by x. So we transfer this x to left hand side and this capital X to right hand side. So we write x is equal to 1 by x. That means small x is equal to 1 upon minus 4. Then small y is equal to 1 upon capital Y. So write here 1 by 2. Then small z is equal to 1 upon capital Z. So 1 upon 1 we get 1. So the value of small x, small y, small z as 1 upon minus 4, 1 upon 2 and 1. So in this way first we substitute, then we use the determinant for solving the linear equations.